Welcome back to Scaling Theory. My guest today is Scott Page, distinguished university professor of complexity, social science, and management at the University of Michigan and an external faculty member at the Santa Fe Institute. Scott is an elected member of the National Academy of Sciences and the American Academy of Arts and Sciences, and a recipient of the Guggenheim Fellowship. His books include The Difference, Diversity and Complexity, The Diversity Bonus, and The Model Thinker. In this episode of Scaling Theory, Scott takes us through what complexity actually is. He unpacked the difference between complicated and generally complex, explain why diverse teams systematically outperform homogeneous ones on complex tasks, and what that means for how organization scales. We also take up path dependence, the spillover effects of overlapping games across platform ecosystems, and where complexity tools have changed real decisions in practice. We close on the single open problem whose resolution would most reshape our understanding of social systems. As you will hear, Scott's thinking is exceptionally clear. It is always a pleasure to talk with him and to listen to his insights. I hope you enjoy our conversation. Well, thank you so very much for coming on the podcast. As we just discussed before starting the recording, I have a couple of your books just sitting next to me. So it's nice to finally put a face and a voice, more than that, on those books. What I've done is that I divided the questions in three parts. First, I would like to understand, as we say in France, where you're coming from. So what's your background? How come you got interested in complexity science? Second of all, I would like to talk about diversity. It's one of the many themes that you have researched, but something we've never even mentioned in a podcast. So I would definitely enjoy having your take on that. And third, I would like to talk about complexity in practice. And in fact, just this morning, I was watching a video of you at the European Central Bank, and you managed to bring complexity insight to policymakers and people with no background in the space. I think is very impressive. So on that, let me actually start with a question I never asked on the podcast.
Okay.
I figured that you would be the right person given the span of your research. If you had to choose three individuals, now dead or alive, to sit at a dinner table with you, who would it be?
Yeah, so it's a fun question, right? It's kind of a traditional question, but it's a fun one. I just came back from a conference at the Santa Fe Institute on kind of can liberal democracies hold? And when I read this question, I was like, oh my goodness, I just had that conversation. It was just with Sam Bowles and Josiah Ober and my wife Jenna, and we were all talking. So it's like someone who studies federalism, someone who studies economic systems, and someone who studies like the ancient Greeks. But like from that, what I really just almost painful to me was like if Eleanor Ostrom had been here, if Doug North were here, and if John Holland were here, and so it's hard because it would kind of depend on like what question I wanted to get at, right? So if I wanted to think about institutions and culture and diversity and how do institutions affect levels of diversity and that sort of thing, I'd really like to, have, someone like Doug North and Eleanor Ostrom and maybe Asimoglu, who I just think is astounding, right? And have a conversation. I'm also just becoming super fascinated by the notion of categories. Now, humans create categories and the heterogeneity and how we create them and how these LLMs create categories and whether it's by exemplars or rules and those sorts of things and how categories aggregate. So for that second discussion, I'm going to cheat and have two answers. It would be Eleanor Roche, who kind of came up with kind of the efficient category stuff. Carl Friston, who's just does this amazing stuff on the free energy principle that I'm trying to make sense of. I heavily edited an article he wrote for Collective Intelligence that I can't recommend enough. It's got like 20,000 downloads and it should have 20,000 more. It's just an incredible article. So I think those two, and then John Holland, because, John and Carl are playing a lot with this notion of kind of signals and boundaries. John has a book on this that was the last, kind of new idea book he wrote. And oddly enough, Princeton makes this really nice link between this notion of kind of like species and parts of the brain create boundaries, and then they get signals to those boundaries, and then these things happen within them. And that's true of firms, that's true of brains, that's true of ants. And like, where do you draw the boundary, and how permeable is that boundary? Is just completely fascinating. And there's so many questions in that space that are just kind of mind blowing. Like, I was just reading a book on um, you can think of like your family and your dogs. Like, we think of there being a firm boundary around like my family and my dogs. Each one of us is like, here's Oda, here's Roland, here's my wife Jenna, here's my son Lorraine Cooper. But like, if you look from the perspective of bacteria, we're really porous. We're sharing a lot of bacteria swapping. Like, every time I pet the dog, and it's just it's and so there's deep questions there that I'd love to, like, Rosh, Princeton, Holland would just be the absolute right people to play in that space.
Yeah. It's with a friend of mine, Nicolas Petit, whose name will be familiar to some people listening to the podcast. We've been watching some of Carl's video, and there is this one interview in which he says, "So I was sitting at the desk, and then asked myself, what is life?" And this kind of like big questions, we always find that to be quite an interesting way to approach science when lawyers tend to comment about whether the comma was put after or before, and whether this was a good idea. So yeah, I'm trying also to get acquainted with his free energy principle and the Markov blanket and the the willingness to survive as a group of indeed cells. It's
Yeah, I mean, jump to your third category, right? This is Jeff Mulgan, who you may know, right? Who's a complexity guy, collective intelligence guy. I just sent him an email like last week saying, like, should we write an article called like why policymakers need to know what a Markov blanket is? Because I think you do, because because the Markov blanket is saying these are the things I need to know kind of before and after this. Like, if I'm really interested in improving education, I've got to have the Markov blanket for education. And it's a really useful concept. I always joke with my undergrads, it's too bad Markov's last name wasn't like Smith, because like these names like Markov and Lyapidov sound so scary that people think they're hard, and actually the idea is really
yeah,
not hard.
Smith blankets. Maybe you should
Bob,
name that.
Susan's blanket, it'd just be like so easy to no
Right.
one would be afraid. It'd be comforting.
That reminds me of another joke by Larry David, who in one of the Curb episodes says, "Well, if only Jesus was a woman, you would get way more people into the religion." Anyway, joke aside, I'm thinking Larry David because he will be one of the three person I would invite on the table, I guess.
They-
If so, we talked already about complexity quite a couple times. How come you one day, or was it an emergent process, became interested in that? Do you remember one specific moment, or was it something that kind of, eventually emerged?
there's two moments, right? So one is I was had this great fortune of being trained by Leo Hurwitz and Stan Ryder, and primarily in Roger Myerson. But Hurwitz and Ryder were, old school economists who kind of developed the field of mechanism design. And the question there was, which works better, markets or central planning? And so this is a fundamental debate. This is Friedman, Lang and Taylor, just, you know, post, heart of the Cold War, like, and, even, Marshak, Williamson, boundaries of the firm sort of stuff. Like, where should we have markets? When don't we? And I had come to economics from math. What happens? I was getting a PhD in math, and Ken Rogoff became a famous economist, was a young professor at Wisconsin. He said, "Look, there's this new thing called game theory. This is 1985 or 86. You should switch and go get a PhD in game theory because it's just so cool." So I went to Northwestern, got a PhD in game theory, and super excited about it. And then, like, my fourth year there of school, somebody, Carl Simon, who later became a colleague, gave Stan a copy of John Holland's book, Adaptation, Natural and Artificial Systems. And Stan and Leo were like, this seems important, but like, we just can't make sense of this given how we think of things, right? It's just, and so I carefully read the book, and then I gave a seminar to people there saying, here's what is in this book. And I think it's really, really cool. I thought genetic algorithm and just seems fascinating. And then Ken Arrow invited Stan to come out to Santa Fe. I think it was Ken, but Stan said, look, I don't have time for this. It's in the summer. Why don't I send Scott out? So I took a train out to Santa Fe Institute. And what I still don't fully understand about myself is I was really kind of at the vanguard of game theory. And there was a career in front of me that was like, I had jobs at Stanford and Caltech, like, just be a game theorist. Like, you're early on in this, you're skateboarding downhill. But something about complexity just resonated with me. And I remember I gave a talk at the University of Chicago, and I said, if I had one word to describe the economy, you choose equilibrium or complex. and everybody said equilibrium. And I was like, okay, this is why. That can't be right. I mean, look at the stock market. Look at, it's kind of like, they're watching a river and saying, look, a sequence of equilibria. And it just didn't resonate. Since I think, kind of I came from a rural area in Michigan, still don't have like, some massive desire for academic prestige. I'm just more interested in the questions. It just seemed like this was right. It just seemed at the level of first order approximation, saying the economy is complex, saying society is complex, saying political systems are complex, makes more sense. Now, saying they're in equilibrium may be more scientific, and certainly at that time, before we had high-speed computers, it was. But I don't even think it was a bet. It wasn't like I sat down and drew a decision tree. It just seemed like this is, more interesting, more correct, more fun.
So in between equilibrium and complexity, you choose complexity. You define it as occupying the space between order and randomness. And within that space, the question I will have for you is, what are the necessary conditions for a system to be generally complex? And maybe you could also say something about why you need moderate amounts of those things that makes a system complex.
Yeah, so this in this book I wrote called Diversity and Complexity, I talk about kind of two classes of definition of complexity. One are kind of the statistical ones, which I call BOR, BOAR, between ordered and random. And so if I look at a time series, if I'm looking at data, if it's ordered, it's not complex. And if it's random, it's not complex. But in between those two, where there's like the description link, and these are things like description length and stuff like that, right? Or predictability, those are kind of like good kind of like proxies for complexity. There's another class, which are kind of like, if you look at the thing itself, you'd say, is this thing difficult to explain, engineer, or evolve, or predict, right? Like, is it lots of moving parts, that sort of thing. And then there's also kind of within that one, there's this notion of kind of what produces it. And what you need diverse things, right? You need those things to be adaptive, so they can't be, necessarily, they've got to, and this is where you run into a very serious psychological problem, because even if they're adaptive, that means that they're probably following a fixed rule. And then you can say, oh, yeah, but they're evolving the rule. Yeah, but then the rule they used to evolve the rule is still a fixed rule. So it's kind of like turtles all the way down. So you can think of rule-based behavior as opposed to adaptive, right? The third thing is they're in some sort of interaction topology that isn't entirely centralized. So they're not all getting the exact same information. And then the fourth thing is that there's got to be meaningful interdependencies. And John Miller and I, in our book on complex adaptive systems, we basically had what we called kind of like the barn theory, which is the big area of real novelty, that if you pull any one of those things to their extreme, you kind of lose complexity. So if I make the rule-based behavior, you can think of as kind of like heuristic-based. If I make people really, really smart, then the system will go to equilibrium, like game theory. So game theory works with small number of players, repeated situation, large stakes. You're probably going to get to an equilibrium, right? Same thing with the interaction topology, right? If I make it, it's got to be kind of crunchy. It's, it can't be like everybody's meeting or people are completely in isolation, because in either one of those settings, you're going to go to an equilibrium, right? The interdependency thing is different from networks, because it could be we're all interacting, but we're all connected, but those connections don't have big effects. So there's got to be some sort of like nonlinear positive feedbacks, negative feedbacks, mixture of those things in the interdependencies. Too much of that, you just get gray goo. Too little of that, right, you're going to get kind of an equilibrium system. And then last, the diversity thing. If no diversity, it's probably predictable, right? Everybody's completely diverse. Then you're in what Warren Weaver would call disorganized complexity as opposed to organized complexity, and you can start doing statistics. You're going to get kind of laws of large numbers. So it is kind of, in fact, this is the thing I learned too late in life, is that like these book publishers don't let you name your books. Like when you sign the contract, it's like they have ultimate naming rights. And so like I have that book was supposed to be called The Interesting In Between, right? And it's called Complex Adaptive Systems. And my book, The Difference, is like named after turns out like a band when I was an undergrad was called The Difference. That was not what I wanted to call the book. But I wanted to call it The Logic of Diversity. But oh well, you do what you do. But I think that this idea of complex adaptive systems is occupying this in-between space is fascinating, because now let's kind of do meta level complexity thinking, if I have a system that's in equilibrium where there's incentives, like suppose a market actually got to equilibrium, well, now it's predictable. And if it's predictable, people and now AI are smart enough to kind of like exploit that predictability, which is going to then, by making new connections, by being diverse, by introducing new things, and that's going to drive it towards complex. Now, if things get too much towards gray goo, and then you got like a statistical distribution, now a simple rule will predict that's going to make it less complex, right? And so I think there's this. I think the fact that that humans and organizations are adaptive and that we categorize things and we look for patterns means that if it gets fixed, we're going to find some new way and make it complex. And if it gets completely random, we're going to just be able to pull back and take averages, which is then going to make it more predictable, which is going to. So I think that we kind of stay. If you think of the economy and social systems like a ping pong table where a ball's bouncing around, we just keep the size of that ping pong table appropriate, so that things are just going to remain complex.
Yeah, we are staying in between, but the two walls
Change.
are moving slightly. This book has a blue cover. Is that right?
Yeah. That's right.
Yeah, for context, we also just talked about how to rank books, and I was telling you that I rank them by color, and it's a good way for me to remember where they are in the library. Okay, so a final point of definition, but that's also a very important one, which is the difference between a complex system and a complicated system.
Right.
So complicated, you give example, aircraft, tax codes. For sure, it is complicated, not necessarily complex. So what are the few principles that listeners should keep in mind to distinguish between complicated and complex?
Yeah, the big difference. I mean, and strangely, the examples that we give in the book are no longer true. Like the classic example of a complicated system is something like a mechanical car engine, right? Because if you go in there and you rip out one part, it's not going to be robust at all because the system doesn't adapt anyway. So individual level adaptation doesn't occur in a complicated system. It's a type, you can think of it as like an engineered system. Whereas complex systems, like you can lose God forbid, but you could have like there's people who've lost portions of their brain from like shrapnel. Or an example I always give with like when my colleagues go on a sabbatical for a year, and then they think like, oh, I'm this important professor at the university, I play all these fundamental roles, all of their self-worth comes from this, and then they're gone for a year and they come back and people are like, oh, were you gone? Like no one even knows. Like the university gets completely robust. You could like lose 5% of the faculty, and a lot of the work on kind of like small worlds and network robustness, just even the simple stuff on network connectedness doesn't depend on removing a few links. But it's the adaptation is one big thing. So the adaptation makes it robust. It also means that the ping pong table, the whole, it just keeps moving. I think one way to think about this is, my wife wrote a book on this called The Robust Federation, is this distinction between robustness and stability. So you think of a complicated system as being like, it's like a basin. So the ball goes back into the basin. So it goes to the same equilibrium. If you think about something like, let's take human psychology, which is a good example. Like our minds are complex. And if we have some sort of disturbance, whether it's some sort of new thing that comes in, whether it's a loss, we lose a parent or something, we're not the same person after that, right? But yet our psychological makeup, our personality, our behavior, but we're robust to that shock to the system. But in order to kind of be robust to that, we become a different thing, right? So you think about how firms responded to COVID. Any firm that just had a really complicated process probably just collapsed. And firms that had more complex process, ended up being robust and recognized like, no, and the system could somehow evolve. So you want to think of the individual parts evolving and the systems and the system itself evolving as being kind of the key determinant. So it means complicated systems are way more efficient typically than complex ones, right? Because they don't have all this extra diversity and extra connections and, and everything's planned, but they're then as a result, like way more less robust.
Yeah, okay. So that's the perfect segue to part 2 of the conversation on diversity, talking about performance and survival of firms in the context of COVID, or, the ability to be a well-functioning human being. So before we get into the nuances of the kind of diversity that matters and why, could you give listeners a first level intuition for why diverse group tends to outperform even the most talented individuals? And we mentioned quite a few already, right? But
Right.
those will be outperformed by groups. So what is the core mechanism behind?
This is a really, I think, super important question because there's a lot of discussion about, meritocracy and ability and discrimination, especially going on in the United States right now. And there's a question of like, and diversity often gets categorized as kind of like wokeness in some way. But the way to think about this at a very abstract level first, and I'll give specific mechanisms in a second, is that the dimension, once the kind of complexity or dimensionality or even complicatedness of the problem is too large for an individual, then when you rank people, you're getting kind of a narrow, the best people are kind of like, they can't see the full show. They're only seeing a part of it, and that makes the group better. So but the mechanisms by which it works depend on the task. And this is where, like, we'd love to say diverse groups are better because of X. And what instead we have to say is diverse groups are better at prediction because of X. They're better at problem solving because of Y. And they're better at coming up with creative ideas because of Z. So let's do each of those. So let's start with prediction. So in prediction, let's think about what happens is, if you say to me, like, what do I think the market share will be for this product, right? Or what do I think will happen if the U.S. invades Iran, like which just run Iran? What happens is each one of us has these models in our head. Now, the reality is much higher dimensional, much more complex. I mean, it's not going to be predictable. Each one of us is kind of seeing a part of it, right? And so you can write down some very basic statistical theorems that show that, like, if we average, well, first of all, you have to have people who have roughly similar kind of ability, right? You have a bunch of people with roughly similar ability, then they're seeing different parts of it. And so if we average it, what we're going to get is we're going to end up doing better. And there's some things like that. There's something in the book I call the diversity prediction theorem, where you can show the crowd's error for numerical prediction will equal the average error minus the diversity. Now, you can think of that diversity as noise, but what the diversity is really coming from is people having different, predictive models. So, if people have different biases, they're going to cancel out. But another way to think of it is, like, if you were going to say, let's suppose I'm going to make 100 predictions about whether or not people are going to repay loans. And it may be that, like, the very best person, figuring that out is someone who's really just knows housing prices and regional economies really, really well, right? But there might be, somebody else who, looks at these things and looks at kind of like what job someone was in and does detailed analysis of jobs. And that may not explain very much. But the thing is, there may be some cases where that's giving an answer that's very far away from what the other one's doing. And it turns out, and if that person's right when they're very far away, when you include them in the mix, you're going to do a lot better. But so the point to take from the prediction literature is that, like, it really is diverse models. It's diverse ways of categorizing things, right, that make groups do better. Now, and the data on this, so when I wrote the difference, there wasn't a lot of, there was data from experiments and some, small examples. But then since then, there's been hundreds of papers, and the effect sizes are massive. So the thing I was giving at the European Union that you're talking about is, like, if you take professional economists, and this is work by Jack Saul and some people at Duke, like, and you have them, this is in the European Union, where they have 43 economists predicting, like, the 6 main economic indicators, like unemployment, growth, that sort of stuff. If you just take, like, 7 random economists, they're like 20% better than one random economist. And the very best economist at a time is only like 10% better than a random economist. And why is that? It's because they've all got slightly different models. And so the other thing we've learned is also that, like, you don't need 1,000 people, like 7 people works. So let's go to problem solving. Problem solving is a different thing, because how does problem solving work? Problem solving works by, like, I represent the problem somehow in my head, right? And then I apply heuristics on top of that representation, which is kind of different than a model. Like, I might have a heuristic like do the big things first. I might have a heuristic like hill climb. I might have a heuristic like go down if it's like simulate an kneeling, like go down if it's not too small, then go up. And there's a famous paper by actually David Wolpert was at this thing I was just at in Santa Fe called the no free lunch theorem, that across all problems, no algorithm is better than any other algorithm, because if you look across all problems, they're random, right? So what it means is for any particular problem, there's going to be a set of heuristics that kind of works best. But now let's suppose I take the very best problem solver. If the problem's easy, they solve it. So therefore, ability works. Paradoxically, once the problem becomes really hard, odds are that person's going to get stuck on a peak, right? A local peak that isn't optimal. Now, it could be that then somebody else represents the problem differently, right? And there's a Stuart Copeland's idea called the adjacent possible. Like the expert's on a peak, and then somebody else comes along and says, "Have you thought about this?" And they're like, "Oh my goodness, I never thought about that." And it can move them along. So the fact that different representations give you different peaks, or
Mm.
people have different heuristics, allow the diverse group to be better. Let me give a very clean example of this. So David Griffiths, who's a math professor of mine at Wisconsin, before I switched and did game theory, he was at a conference I was at where people were modeling traffic. And one of the things they were saying is that, like, when you do these traffic models, you're modeling every car on like this matrix. So it's these, like, if it's a 3-lane highway, it's a long thing of zeros and ones where one is a car, zero is a not a car. And someone said, like, these things take a long time to process when you get traffic jams because you're just passing a lot of information. And Griffith said, why don't you just model the non-cars? Like, why don't you just keep track of the zeros? Which, and there's very few spaces, and like the room is silent. Like, this is not a traffic expert. This is an algebra. This is a logician, right? But because he's got he's used to seeing like matrices with lots of zeros and ones and saying, oh, sometimes it's just easier to keep track of the ones in a dynamical system. Boom, huge breakthrough. But he would not have been, if you're going to, like, let's hire a traffic modeler, you would not have hired an abstract mathematician from the University of Wisconsin. But when you're putting a group of people together, you would. And here again, evidence. I mean, I feel like I'm in really, things have turned out. When I wrote the new introduction to the last version of the difference, I sort of said I couldn't have imagined that. I mean, some of these things had to be true. They're mathematically true. So it was just a question of effect size. And what's shown across a whole bunch of examples in the prediction case, yeah, the delta, the gain, the lift, whatever you want to call it, is like 10, 20% in serious settings, medical evaluations, economic predictions. It's shocking. I mean, I would have guessed 5. And in problem solving, there's been, Desch and Wu, James Evans, Brian Uzi, all these people. I just got another paper today to referee. People are looking at every single scientific paper ever published, every patent ever issued. And these diversity lifts are enormous. And I mean, having somebody who comes from a different discipline, right, who frames the problem differently, who has a different adjacent possible, gives breakthroughs. And here's where, like, the identity stuff comes in. So, like, a fun experiment I do is, like, I used to call it the Tom Hanks replacement experiment. Now I call it the Taylor Swift replacement experiment. But I say, Tom Hanks is going to do a movie. He backs out at the last second. Who should fill in? Well, if I have a room of dudes, they just think of other guys. It's like Liam Neeson, right? It's all dudes. But if one woman's in the room, she'll be like Meryl Streep, right? Well, once you think of Meryl Streep, it opens up a whole range of other actors that you didn't think of, right? And white people won't think of Denzel Washington, right? But once you think of Denzel Washington, then you think of not only African-American actors, but Latino actors and people from other countries. Also, so it opens up a bunch of stuff. Last one, on creative tasks, it's a completely different logic in the sense that, like, now it's kind of the adjacent possible, but it's like if you ask people to think of ideas, like, we measure creativity by how many ideas you can think of. But if you've had a different set of life experiences, you're likely to think of, or been trained in different ways, you're just likely to think of different uses. So, like, a famous test is like the brick test. But if I give you like a pen and say, what are the uses of a pen? Depending on what your life has been, you're just going to think of different things. And so your individual ability is how many ideas you think of. But your idea in a group, your value to a group is how many novel ideas do you think of? And so, again, and in all of these cases, if you took the best person, or if you chose like the 10 best people, often you're going to be choosing, those people are going to be very similar, because, like, the best person to predict the economy might be an economist. It's like, I would talk, like, when I talk to the European Central Bank, or I would talk to the New York Fed, and I would say, if I'm going to hire 3 people to look at poverty, I'm going to hire 3 economists. If I'm going to hire 4, I'm going to have a sociologist. If I'm going to hire 5, right, I'm going to have somebody who's a criminal psychologist, right, or someone who studies, because at some point the margin of return, ironically, margin of return to economists gets really low.
Yeah.
Right. So it's not, I mean, but again, in the one case, it's different models. It's in the other case, it's different heuristics and representations. And in the third case, it's kind of like and this is why I brought up Eleanor Roche, it's just different. We frame things so differently, like different categories. And then the diversity comes in 2 parts. There's the kind of immediate gain, and then there's this kind of interactive gain, right? Like, when I do prediction contest, where you really get a benefit is when 2 people, like, come up with very different predictions, right? Because they can't both be right. And typically the average is not good either, right? So then you figure out, okay, which one of us is right? But that means the group is going to be kind of way better than the average person.
I was playing with the concept of adjacent possible just last week, actually, in the context of the regulation of Gen AI, coming from the perspective that, well, when we think about Gen AI, we think about chatbots, but this technology will also power other technologies. So what does it mean to regulate one that will recombine and will eventually make something else possible tomorrow? But to come back to what you said, on the different gains you will get with diversity, have you observed some power laws or something that will kind of, always get you to, you mentioned 20% gain? Do you think it is possible to model that, or would you say you will have more diversity in the gains you would get?
So it's fascinating, right? This what relates to complexity. And I'd like to go back and maybe rewrite the diversity and complexity book. So Google did a big thing on like how many people should you have hiring someone, right? And they found that like after 4, there's not much of an advantage. With The Economist, they found that like after 7, there's not much of an advantage, right? And these are huge data sets. But then Preston McAfee and anyways, a bunch of other people on this paper where they looked at predictions in European soccer leagues, right? And there they get that like you can get to like 8 or 9. And if they're talking to people about this, a number of people about this, it appears to be that the number of people is some product of the complexity and the sophistication of the people making the predictions. So the more sophisticated people are, the kind of less you need, the fewer you need, right? But the more complex the thing is, the more you need. And so the European economy is probably more complex than soccer, but economists are way more complex sophisticated in their models than the people betting on European soccer, which is why you need 10 of them and 7 economists. Now, the case of like 21-year-olds that Google's hiring, they're not as complex as the European economy. And you don't have as much data on them and time series. So therefore, that's going to fail up. That's going to stop at 4, right? Because there's just not enough signal there. So I think that like there probably could be a theory somewhere where you could say, here's and this is the kind of thing that AI could probably do in 20 years. Imagine 1,000 or 2,000 studies on carefully done on group size and predictability. I bet if you had some sort of crude complexity measure on this axis, and then you had some crude sophistication level on this axis, you'd get kind of level curves there, right? That the higher the complexity is, the more, if the level of sophistication, if the level of complexity is kind of proportional to the amount of complexity, then maybe there's just a line of 7s across
Yeah.
there, right?
Yeah.
But then if they're less sophisticated, then I'm gonna need more. And if they're more sophisticated, I'll need fewer. But what's an open question right now at the moment is, at least I see it as open, is like when we think of AI, we often think of like one big model, but there's a lot of these mixture of expert models that they're using, right? And everybody's saying, oh, use multiple AI. And so there's a question of like, how many AIs do you need?
Yeah.
Right.
Yeah.
And again, I think it's going to depend on the question, but not in a random. I mean, my son's joke that like with 2 social scientists as parents, the answer to every question is it depends. But which is true. But I think it also can depend in a scientific way.
Of course, we multi-home, right, when it comes to AI, and I guess you've been doing that, right, where you prompt the very same and you compare the results. But I guess the objective, at least in my case, has been always to try to identify for a specific task which AI model is best. So I could always use just that one and then kill the diversity. So maybe you are making me think that this is not such a smart way of proceeding.
But also, you're in the room though, right? And so it's probably also the case that like you decide like neither one of these things is working, right? And I think that's one thing that I'm really trying to grapple with, because it is an alien intelligence, right? And that like it's taking high dimensional projections of things and mapping them. And I try to remind myself and my students all the time, if you look at things like, kind of classic factor analysis studies, like my colleague Ron Engelhardt, who recently passed away, like who did the World Values Survey for 30 years, right? Or 50 years, surveys people from around the world on 66 questions, and then did this, factor analysis techniques to then map countries in 2 dimensions. But each of those dimensions was a 66-dimensional projection based on questions. And you get different regions of the world. If you type in world value surveys, different countries and different regions are all mapped near each other in this 2 dimensional space. And you could reason from that. But the thing is that we can't reason from that because each of those dimensions is a 66-dimensional projection, And so I can put a term on that. And this is, I think, where I don't know if we delude ourselves or it actually makes sense. I could call one of those things individuality or something, right? Or individual expressionism or something, or, but like, what does that mean, right? And we do this a lot in social science. And this is the thing I'm really trying to understand and can't is like one of the papers given at Santa Fe, people were talking about rule of law and showing rule of law explains all these things. And if I say rule of law, especially someone like you think you know what that means, right? But then you would have a sense of rule of law. But the formal measure of rule of law is a scoring across 8 questions that are somewhat related. And there's some sort of belief that though there really is a thing called rule of law, and I see the residue of this in these 8 questions, and the average of the 8 questions actually has much better statistical power than any one of them. And I think the underlying logic is, the reason, and that's proof that it really is a construct, because each one of these things is a noisy measure of it. And so when I average them, I'm getting a measure of a true thing. Yeah. But what AI is doing that not just with 8 questions, it's figuring out which 11 million things it wants to weight on this thing and predict from. And so it's predicting, what it's doing is completely different than what we're doing. And as I become more sophisticated as a social scientist, theory of mind becomes more and more important to me. I realize a lot of game theory, a lot of my behavior depends on kind of having some understanding of how other people or anybody's behavior, how other people are going to respond and react, right? So today, when I learned that the new leader of Iran, not only did his father die in the bombing, but his mom, his wife, his children, you just start thinking from a theory of mind perspective, like, okay, how is this person reacting to the United States, as opposed to imagine it was someone who didn't just have those things, right, happen to them. So I can think as a human being, have some folk understanding, we've got pretty good folk psychology, most of us, right, that how someone might feel about things, but I have no idea how an AI responds to something like that.
So to conclude on diversity, you've talked about science and how you see yourself as a scientist, and the objective of some scientists is impact. And I think what I'm getting at, you also did some work and some research on good strategies in order to maximize citation ratios. I've seen you talked about patterns, whether you want to work as a team, whether you want to single author papers. So if you could get the idea, the underlying idea, this would be very helpful.
Yeah. So this is me kind of riffing on other people's work, which is fascinating. So there's, so some of this is Melissa Schilling, Dashan Wu, James Evans, Brian Uzi. There's some work by some people at Harvard whose names I'm forgetting, but like essentially if you want to like pick someone, you're better off co-authoring flat out. Right. And if you want to have high impact science, and Dashan has a fabulous new book on this called like The Science of Science, or maybe it's The Science of Scientific Teams. But what you want is people who are different from yourself who are really talented. And so when you look at like the original work by Ben Jones and Uzi and Mukherjee, it kind of shows that like there's a 4.5-fold increase from working with diverse teams versus, kind of like working on your own. And there's 3 parts to that. One is, so think of there being a +1 from we tend to work with other people who get a lot of citations. We choose to work with people who are good. There's another +1 that comes from working with people who just look at different stuff, right? So they cite different papers, right, than we cite. And then there's a bonus of 2 if you have both of those other things. So if you just go for citations, you kind of get 1. If you just go for diversity, you get 1. If you go for diversity and ability measured by citations, you kind of get 4. You get 1 plus 1 plus a huge externality of 2. But even things like, Melissa Schilling's work, which is kind of fascinating in the social sciences, if I walk down the hall and work with someone from Michigan versus calling somebody up from University of Amsterdam or Ohio State or UCLA, in the latter case, I'll get 10% more citations. And the I'm sorry, you get a 10% increase of writing a paper with 100 citations, which, so I can't remember what the exact effect size is for a number, but I'm much more likely to write an important paper. And I think the reason why is actually really straightforward. It's that, and here's what I've done kind of like loose qualitative work. If you look at, let's take, this is something for NASA I did just for fun, is look at fluid dynamics, advanced fluid dynamics, and pull up for a graduate advanced fluid dynamics course, pick up the syllabus from MIT, Michigan, Illinois, and Stanford, which may be like, 4 of the top places. There's not that much overlap. And you're like, you're kidding me, this is fluid dynamics. But like at MIT, they do windmills, and they use windmills then as a way to get into propellers. At Illinois, they do water flowing over rocks, because there's a lot of people who do glacial stuff there because, it's in a glacial moraine. And in Michigan, which we also have a top naval architecture program, there's a lot of people doing stuff with ships' hulls and things like that. So to prepare you for other classes. And so if you take, here's a clean example, even a clinical neuroscience, like last year, probably 75,000 papers, right? So suppose I'm hiring postdocs, and I hire someone from Princeton, and they're amazing. And then next year, the same person in Princeton said, I have this incredible postdoc, as good as the one you hired last year. You're thinking, I'm going to hire her because the previous one was good. But think about it. At most, they're reading like 200 papers a year, right? So maybe they read 1,000 papers when they're in grad school. I'm getting someone who's got an overlap of 800 out of 1,000, maybe, right? So between them, they read 1,200 papers. During that time, over 250,000 papers were written. That's probably the last person I should hire. I won't name the university, but one university, the provost had me come in because she noticed a tendency of people to hire research assistants for her young faculty, to hire research assistants from where they'd gone to school, or from their advisors from her students, because they knew the same techniques and had the same skills, and they could get things out fast. And the evidence is kind of overwhelming. That's a B+. That's how to get a B+. Because you're just, seeing narrowly. And so she basically just had me get up and just keep showing other people's empirical work and just like, look, this is how to be mediocre. You're just, you are like playing the mediocre card here. But it's hard, right? Because it's also true that like diverse teams do best, diverse teams also do worse because they're harder to manage. And so it's a risk aversion. People feel like I can get tenure by playing the B+ strategy.
So let me move on now to part 2 of the conversation, although we already talked about complexity in practice quite a lot. Yeah. But there's a couple questions, and one of them is totally self-interested because it's a concept that I use a lot in my own work. So let me start with that one. You've worked on path dependence, and you make a distinction between outcome path dependence and equilibrium path dependence. This is in a paper that I will link in the show notes. Right. Why does the distinction matter in practice?
Yeah, so this is fun. These were my undergraduate. I was taking an undergrad class on models, like for this models thinking book I wrote, right? And these were my notes on that. Someone's like, you should so write this up as a paper, because they were on the web. And so this new journal started called the Quarterly Journal of Political Science, which is now like one of the very highly ranked journal. And the editor's like, we would so love to have that paper. And I'm like, that's my undergraduate notes. But with the point you raised was the one that like why they wanted it is that, so let's think about path dependence means is we typically think, oh, it's path dependent. What happens at time t+1 depends at time t, right? But that could be true, but that doesn't mean that what happens in the long run doesn't matter at all. So there's Upton Sinclair who writes about the railroads. Like once you get the idea of the railroads, it kind of doesn't matter, which section of track gets built first between what cities, where they're going to go. And the irony of that is like now we know slime molds can basically, like if you put sugar deposits proportional to the population sizes, slime molds can reproduce the Tokyo subway system and the English rail system just by like finding major paths between the largest sources of food, right? So what the railway system is going to look like, but at any moment in time, the next track that is laid is completely path dependent. So the path dependent of the event at time t+1 does not imply that the outcome itself is path dependent. So it really raises the level of explanation you need, right? You can't just argue, oh, because what happened now depended on what happened in the previous period, that means that what happens in the long run is somehow extremely sensitive to initial conditions. You can't pull out the overused butterfly metaphor. No, 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 no. That's a good try, but like that's just not. It's sloppy thinking, right? You gotta kind of model the full system. And the other thing that comes out of this is that like people equated path dependence with increasing returns, right? And you don't necessarily have to have. In fact, like just any sort of massive interdependency, right? I mean, think of like middle school relationships. There's not a, that's not described by simply increasing returns. It's described by massive externalities like the frenemies. And I always joke that middle school and international relations are the two most complex. But like, but international relations is the same way, right? Like there's positive feedbacks there, but there's all sorts of wild interdependencies, right? World War I was a path dependent event, right? And there were positive feedbacks that then began, but it's really like a nexus of interdependencies. And so this distinction is really, really important. And I was happy to publish the paper because I thought this is really making just a really clean, like 3 or 4 really clean, simple points, but outcome versus kind of, equilibrium versus outcome dependent, path dependence versus increasing returns. So the whole idea was this is a really exciting concept. Let's try and explain it in really simple terms and be really careful and not flap our butterfly wings too often.
Yeah, I think you managed that very well. And I want to talk about another concept where it's actually 2 papers, at least that I could find, where you make another point that is very clear cut. And that's your work with Jenna Berdnar.
Yeah, my wife. Yeah.
And I wonder if you get asked a lot about it. But in my view, this is one of the most important results in your portfolio. So what you show, the core idea is that behavior in one game bleeds into other, and people carry spillover heuristics. So what does it mean about how we think about platform ecosystems, right? The digital platforms that we use every day, where users play many games at the same time across one infrastructure, right? I'm thinking Google playing many games by deploying many products at the very same time. Is there something we can learn from that?
This is the conference at Santa Fe was in this space, and Sam Bowles has a bunch of papers in this space. Asimoglu has a recent thing on this. Alberto Bicin has a lot of work in this space. Rachel Fernandez. But here's the general idea: like, how do we think about culture? And so, if you think of like, you can take culture as given. So first, what is culture? To be an anthropologist is to have your own definition of culture, right?
Yeah.
But in
I
some
was
sense,
thinking of David Foster Wallace, right, with the 2 fish.
exactly. That's exactly. No, I use that example all the time, right? What is water? And but let's think of it as beliefs, behaviors, routines, artifacts, all that sort of stuff. It's undeniable that when I put an institution in place, what's going to happen is I'm going to affect the culture in some way, right? And that culture, then, if culture matters, and this is what I think economists are trying to figure out, and sociologists have been claiming is true, and it is true, right? Is that culture affects outcomes, right? So levels of trust, right, matter a lot for economic outcomes. Trustworthiness matters more, right? Other regardingness matters, right? When we think about kind of sophisticated coordination games, do I have the capacities to coordinate, right? So Roberto Weber, who's a grad student at Caltech, actually, I think the first grad student ever admitted, what luck, right? I think it's the first file I looked at. I'm like, wow, Caltech gets great applicants. But it turned out like it was Roberto Weber. But he has this great paper where like, if you can't just get 8 people to coordinate in this game, but if you you kind of can't do like sophisticated coordination, but if you start with simple coordination, then you can learn to do more sophisticated coordination. And there's a massive literature on, kind of framing effects in games. So now you get to this like really cool question. If I choose an institution, like, I was trained by these mechanism design people, I get an allocation, an outcome, a decision, whatever, right? But I often use the phrase kind of like beyond allocation. I also get for free a culture, right? I get effects on culture. And so what's undeniably true then is that if I'm choosing a sequence of institutions, right, if I'm collecting an ensemble of institutions, the culture is going to be a product of those institutions. And then the institutions I choose are going to be a product of the culture. So you can imagine culture and institutions as co-evolving. So in the experimental work, that was done with Tracy Liu and Yen Chen, we showed these spillovers, and other people have shown them as well, right? That like how I play in one game, if I cooperate in one game, I'm likely to cooperate in another game. I think that the deep question here is and this is why this whole conference on will liberal democracy hold is when we think about what institutions we put in play, how much should we think about the culture they produce? And here's an obvious point, but I have a paper that who knows if it'll get published. It keeps getting rejected, which says the following, that equilibria, Jen and I have one paper that just came out in GBO that makes this point. The equilibrium in the kind of culture institutional space is generically not efficient. And the reason why is you're exactly balanced. So you want to think of like institutions both leverage and produce culture. When you're in equilibrium, they're kind of optimally leveraging the culture, but you're not taking into account the production of culture. So suppose I've got a level of trust that's 0.7, and I think, okay, I can do two different market designs. Which one works better? And A may work better with a trust level of 7. B may not work as well, but it may increase trust more, right? So the trust after I had this institution, if I add A, may drop it down to 6.9. If I add B, it may raise it to 7.2. Well, if I thought about the effect of the increase in trust on all the other institutions, I'd be better off. And so if when I chose institutions, I thought not only about outcomes, but about the effect on culture and how that's going to go through all the other institutions, I would choose institutions differently. And so myopic institutional choice is generically not optimal. But then you get into this, I think it's a really interesting question. Like if I'm running any organization, this holds at the organizational level. And this is the paper I'm having trouble publishing. Like, because there's a whole theory of kind of like alignment or congruence, that your culture and your institutional structure should be congruent.
Yeah.
And I'm arguing, no, that's wrong. You actually should be choosing your organizational structures to push culture beyond where so that it makes all of your processes work better, right? So maybe you have too many meetings, but you should be trying to choose institutions, choose structures that like create the good stuff, like trust, other regardingness, sophisticated communication skills, those sorts of things. Even if at the margin, they're costing you a little bit for that one interaction or that decision, if overall they're producing the things you want that make everything else work better. So you kind of want to, but again, this just comes down to like thinking your point, like recognize anytime you do something, you're changing the structure.
What I understood from publishing economic papers is that counterintuitive results were easier to publish actually than the results that will, go with the flow of publications. But apparently this is not always the case, which brings me to the next question.
Yeah.
Which counterintuitive results actually surprise you the most while doing research? And I'm asking because, of course, as we know, complex systems, they tend to produce results that are very hard to anticipate, right? So is there something after many years of being embedded in the space that to this day surprises you?
So too, right, the diversity stuff early on, right? Like, so what the quick background on that, I talk about in the book, is that like, I was teaching at Caltech and students were like, we're not going to do manufacturing, we're going to do problem solving. And I'm like, yeah, but this model of diminishing marginal returns work there. And then I started doing simulations and it just didn't work. And we wrote an early paper on that, Liu Hong and I did. And what's kind of fascinating about that is there's been a bunch of people. There's a recent young Italian guy who's been like attacking us, saying, no, here's a case where, and the thing is that like what we said in that paper is that there are cases where, given assumptions, where this really surprising things happen. If you randomly selected people, they do better than the team of the best. There's also cases like a 400-meter relay where if you choose the best people, they're going to do best. And then there's a huge area in between where like a cultivated diverse team is going to do best, which is the larger region. But that one just really, I was calling that like a green eggs and ham result after Dr. Seuss. Like it was true on a tree, it was true on a graph, it was true on a train. It was like, no matter what model we created, we could find assumptions where random groups did better than the groups of the best because the groups of the best ended up being similar. But a recent one, relatively recent, like 10 years ago, that I'm still like, it's a very funny story, is that we were doing the spillover stuff. Jenna Bednar, my wife, was saying like, it'd be interesting to think about, let's suppose that like you and I have to coordinate. So we're playing two coordination games. Like we have to like cross the signal, we can either stay back or we can stay back, or we can go across the signal, and we can either greet each other by shaking hands formally or hugging each other. And supposed to like the looser thing, like hugging and crossing the street, are consistent and being very formal and holding back are consistent. But then I also want to be internally, I want to internally be consistent and I want to coordinate with you. And she said, like, does that take longer to converge? And I'm like, oh yeah, that should be easy to do, right? And so I solved it like in the 2x2 case with a simple Markov model, and then I could not solve the larger model. And so then I went to a physicist, Len Sander, and he's like, "Oh yeah, no, that's easy to do." And then Len went got an NSF grant, and a student did his dissertation on this, showing that like when you have a system of things, like suppose there's 10 domains, and I want to be internally consistent, but then I want to coordinate with other people in my network. It turns out those systems are far, far slower to converge. And then what we found is what was so wild was when we simulated these things. So this was with Aaron Bramson and Andrea Jones-Royce. So simulate a society where people are in a network. We have 8 behaviors. We want them to be individually consistent, but I want to coordinate with other people. And then throw in a tiny error term, like epsilon, right? You get massive heterogeneity. And so, Ron Engelhardt, who'd done the world value surveys, like it's always been believed, and it's true, that these are 2 fundamental processes. People do want to be consistent, and we do want to coordinate. And it turns out that, like, and so if you look at the individual country level scatter plots, you see these giant clouds. And this had always been a bit of a puzzle to Ron. It's like, well, there's survey noise, whatever, right? And like, we're like, oh my God, this is so wild, because like tiny, tiny errors. Because what happens is if I make an error, then it can go to you and you make the same error. And then it spreads both kind of vertically between people and horizontally within people, right? And what the physicists showed, I was on the committee, but I didn't do any, only did a tiny, tiny contribution to the work, is that when you start increasing this is called a higher dimensional spin glass in a way, right? It's like a voter model from complex systems where there's voter models on top of voter models. Convergence really slows, but if convergence slows, that means tiny bits of heterogeneity expand. So the idea that like the reason we see so much heterogeneity within cultures could be that people are trying really, really hard to coordinate and be consistent, but they're just making tiny errors, right? That was like super fun. I love, stuff like that is just super, super fun.
Yeah, no, indeed. All right, let me ask you a very final question, which is a tough one. If I'm asking you here to identify the single most important question in complexity science that has not been solved yet, something, you would dream of solving, which one would it be?
Yeah, great question. And the irony is, like, John Holland's daughter, Manya, sent me an email at this last week. She's starting a new project trying to come up with ways to forecast, like we can sense so much more now. How do we forecast when a complex, like, so she's looking at the Great Lakes, like how can we figure out when something really bad might happen? So Bob Axelrod and I have a paper, hopefully it's going to come out soon, getting advice, like principal agent models for large events. So I suppose there's a power law distribution of event sizes, which is true. So one thing about complex systems, so we talked about them being robust, but when they fail big, right? So, Warren Weaver's whole thing is, disorganized complexity is like a normal curve, organized complexity, it's like a power law. So things can go horribly wrong. So what do we know? What early warning signs do we have about things going horribly wrong? Like, when would World War I break out? When will there be a pandemic? When could we have massive social uprising? When could a transportation, what causes a system, when could we have, we think we know from the historical record, we've had, kind of massive species loss events, right? Punctuated equilibrium. It's a strange use of the word equilibrium, these big events. So can we, I think a really big, stock market crashes. So how can we, what would the signals be to predict the large events better? There's some really primitive models which kind of assume, they're very good, like by Carpenter, which say, like, if I have a peak that's really firm, it's really steep, then evolution is going to keep me at that peak. But as the peak flattens, I'll get more diversity, right? And so there's some evidence that when I start to see increases in diversity within species or within types, that's a sign that the peaks are no longer holding. I'm going to move to a different equilibrium. That's a good idea, but we don't have a good general theory of when would, there's self-organized criticality and stuff, but we don't know when a system is really, other than like things like sand piles, when it's close. I think that's a huge question, right? Because I think we really, the whole world economy is so interlinked. I think that's a really big one. And then another obvious one, I think, is like, how do we, and this is more, I don't even know what the word is. I think it's more existential, really, in the sense that, like, how do we think about applying some ideas from complexity science to understanding what the appropriate use is of these incredibly not it's not just incredibly like we're gonna have communities you mentioned earlier, like communities of AI. We are now it's like there's now a different species,
Mm.
right? And so if you were to say, I'm gonna rewrite sociology, psychology, anthropology, economics, organizational science in a two species model, right? One of which is humans, one of which is AI. What does that look like? Right? How do we and I think that is a complexity science question, right? But that may be a naive framing because it may be that like we really end up with, other species. There may be multiple, like this gets down to the signals and boundaries thing. Will there actually be 5 species of AI?
Yeah.
Like here's an AI predictor, here's an AI organizer, here's an AI, whatever, right? Um, and will we want to keep them in buckets so we can assign them in role, in firm categories, or and I think that will happen naturally, right? I think this is one thing we know from complex systems is you get these kind of emergence of
Yeah.
boundaries, which you're talking about, right?
That's one of the problem I see with current ways of regulating AI, which is that we try to capture all AI system with one definition, but the definition is so broad that if you do even some statistics or supervised learning, this is AI. Unsupervised learning, where it's very hard to come up with, prediction as to what the system will do, is also AI, and they do not represent the same risk for society, and yet they are regulated under the very same rules. So indeed, maybe coming back to the Markov blankets, we need to have, a couple of those different species with different rules
Yeah, and
assigned to each.
the other thing, on this, when you hear about like the regulation, like so we ran this. I took this amazing class in grad school from Art Stinchcombe, who's a famous economic sociologist, called Markets, Hierarchies, and Democracies. And the core idea was we have to allocate something or decide something. We have 3 ways to do it. We have markets, we have hierarchies and democracies. And in each of these, in econ and in business school and in political science, you'll learn about each one of those individually. But you can think of it like almost like DNA, where are we choosing? Which one are we choosing? In different countries and different organizations, choose action D for different tasks. Well, with J.J. Prescott, you may know who's a lawyer, Jenna Bender, my wife, and Jerry Davis, we ran this thing called The Choice at Michigan, where we said, now there's 5, right? So there's markets, hierarchies, democracies. There's also self-organized communities. So things like dating used to be done without a formal institution. This is kind of Eleanor Ostrom's work. But the 5th is algorithms. And dating's a good example because it went from self-organized to now a lot of it's happening with these algorithms. But when you move it to algorithms, you suddenly it's changed who marries whom. It's increased sorting by politics, all sorts of things. Like the fabric of society has changed when you move. This gets to the kind of cultural spillover stuff. When you change any one of those HD, S for self-organized, A to algorithm. But what's happening is we're just flipping things to A, right, at the moment. And we're giving Silicon Valley the authority to flip anything to A, right? It's just presumptive. Like we can dating, we're allowed to create a dating website without thinking of any of the repercussions of that, right? And so and we're allowed to create an electricity trading website without any repercussions of that. So some of that, but then that gets regulated because people realize, okay, that one. So the question is, this is a question kind of to you, but like, I think as a lawyer in this space, it becomes super, super fun and challenging to think about what is the nature of regulation to non-humans, given you can't punish them.
Yeah. Or not, is it?
Right? This is like, systems work because of trust, punishment, and forgiveness, right?
To some extent, if you talk about an AI with unsupervised learning, where you actually reward the system if you do some reinforcement, where the human intervene, you could think of a way of punishing them, right? By not granting the reward for misbehaviors.
Yeah, but do they care?
Yeah, well.
Yeah.
Yeah.
And what does it mean to forgive your AI? I think the fact that I think that regulation become like things could go, and who knows? Like everybody's saying, is it sentient? I think we don't do certain things because of concern that, like, back to my earlier thing about the most important question, like horrible consequences, right? But I just think that like you can't, Like if my algorithm cheats on its taxes, and this is the thing that like there's been a couple recent papers on this, and they get a lot of play on X, but there's been multiple papers
Yeah.
that if you just have AI bots set prices for gas stations, they start colluding, even if you never,
Yeah. I saw that.
and what are you gonna do? Send them to jail? I mean, like Alfred Taubman, who manipulated the Christie's auctions, went to jail. He's one of the richer men in the world. Like went to jail, right? I mean, now you could say I'm gonna send the person who made the algorithm to jail, but like that's I don't know. I mean, you're the lawyer, but I think that's or what if it's a multi-agent system and the cheating is emergent?
To some extent, to introduce two thinkers to the conversation. One will be Adam Smith. So if really what we want is to be loved and to be lovely, and
Yeah,
algorithms behave the same, then that's one way of then regulating their behavior. The other
right.
one is Louis C.K., the stand-up comedian, who says that the only reason why we are not killing other human beings is because we have a law prohibiting it, right? And if that is true, then it's also a different way of regulating. But you've mentioned Bob Axtell, simulation. We didn't get to talk about ABM, agent-based modeling, maybe something for another discussion. Also, the next title of the book, your editor would choose to be collapse of complex systems.
Right.
So maybe just to ask you a very, very final one, what are you working on these days? Is it anything related to what we just talked about?
Yeah, a couple things. So one is I'm working in this. I'm editing a journal called Collective Intelligence. I'm really trying to think a lot about how we produce collective intelligence, but I'm thinking a lot about this space of very broadly defined in terms of like if you were going to redefine institutions now, like markets, hierarchies, democracies, given the affordances we have. So a lot of our political systems, economic systems look the same as they did 50 years ago, right? 100 years ago. How would you, we can now do things that we could never have done before. Let me give a very like so. Lynn Landemore, who you may know, right, is a Yale political scientist. You does create these citizen assemblies, but I think that's just like I think it's fabulous work, and I think it's just the start of this conference called iWord, which is an international workshop on reimagining democracy. Just the start of ways in which you might think of creating systems in institutions that work really well. So we know quasi-governmental things like central bank independence really work a lot better than if the central bank is under the government. But let's take something at like very low fruit, like the pardoning system in our government by the president has gone off the rails, right? And this is not just at the current moment. You can go back. I mean, even Obama didn't have a clear record. I mean, Clinton, the Bushes, right? I mean, it's just it's terrible. But you could, when we wrote the Constitution, it wouldn't have been possible to say, let's randomly pick 50 Americans from the population. We'll pay them $100,000 a year or $200,000 a year to understand, pardon, we'll coach them up, and then they'll serve a 4-year term with the president. And he needs to convince only 10% of them to pardon someone. I mean, we could decide on whether 20%, 2%. But that would then make it so this crazy stuff doesn't happen, and the cost to society would be very low, right? To do that sort of thing. But like in Michigan, we had something like that happen with gerrymandering, where we had a citizen movement to randomly select people who then were trained to draw our congressional and state legislative boundaries, and they did a fabulous job. No one's complaining about it. We completely fixed this. We just did a fabulous fix to the system, not by taking it out of the political arena. It's still political. We're randomly selecting people who then decide on a process, listen to people, and come up with it. But we've made a better outcome. So if you step back and said, I want to design healthcare systems, I want to design economic systems, I want to design educational systems, given what we have, especially now, given what we have is fundamentally changed. Those are kind of that's kind of the big question, that's animating me at the moment. But then I'm also, continuing to do a lot of just kind of like, fun, like I have a paper that came out with Lu Hong on the Condorcet jury theory, and I have a new one hopefully coming out on that as well. Like, I think some of the things we think about like why just selecting and composing teams, I think we can have a science of that as opposed to just kind of like relying on, I think, what are sometimes ideological beliefs about juries of peers, diverse groups, randomly selected things. I think there's actually ways for society and for organizations to make better choices. I'm still super interested in that as well.
All right. So on behalf of all of us and my future self,
Yeah.
Looking forward very much to reading those papers. So thank you so very much for
All right.
all of your publications. Also coming on the podcast. It's been a real pleasure. I hope to see you maybe at the SFI next time I'm there. So I'll
Okay,
get in
awesome.
touch.
Yeah.
In the meantime, to you and everyone out there, take care of yourself. And if you can, someone else too. Bye-bye.